Hello, Earth Science class. I'm coming to you with 5 o'clock shadow and all to share you stuff about the solar system. So, past few days we've been talking about the sun, the earth, and the moon, which are part of something much bigger called the solar system. So we know that the earth goes around the sun. Just wanted to see if you could remember. Earth goes around the sun. So the sun is really the center of the solar system. And when I say that word solar system, I'm just talking about everything that goes around the sun. We call those revolutions. So everything that has a revolution around the sun is part of the solar system. Turns out there's a lot of stuff that goes around the sun besides just planets. So as far as the solar system, I'm not going to make you guys memorize the names of planets. I'm not going to make you guys memorize moons or any of that stuff. Order of, I know you guys maybe memorize the order of planets at some point in your life. I want you guys to know about 4 main zones of the solar system. Truth is, there's so much being discovered every day about the solar system that it's just kind of weird to have you memorize anything specific. But I will tell you about the 4 main zones of the things that are closest to the sun. So first of all, let me show you a very inaccurate map of the solar system. So I'm kind of saying this in a joking way. There's really no way to show you a really good map of the solar system because all of the sizes of these planets you guys are seeing are totally out of proportion. And also they're much closer together than they should be. The truth is that the objects vary so widely in size and space that it's impossible to put it on an accurate map. But you get an idea of the solar systems. And here are the 4 zones we're going to talk about. Again, I just want you guys to remember the names of these 4 zones and the order they go in. I'm going to talk about each one in detail just so you guys get a little bit of taste of what they're about. But I just want you guys to remember the names and the order they go in. So first, we have the inner terrestrial planets. That's the zone that's closest to the sun. Then the next zone is the asteroid belt. And then after that is the outer gaseous planets. And then the last zone we'll talk about is the Kuiper Belt. So first zone, the inner terrestrial planets. These are the closest to the sun. They are solid, dense, and rocky. And if you look at the picture below, you'll see Earth is one of those planets. So yes, we are in the inner planets. We are in the zone of planets or bodies that are closest to the sun. They're relatively small compared to the other 4 planets we're going to talk about soon. They have very short orbits around the sun. So while the Earth takes 1 year to go around the sun, Mercury only takes 88 days, so that's just shy of 3 months. Venus takes 200 something days to go around the sun. Mars is about a year and a half. Now, the planets that are farther away from the sun, like Jupiter, Saturn, Neptune, Uranus, they take on the order of hundreds of years to go around the sun. So, short orbits compared to things that are much farther out for sure. They were all geologically active at one time. Now, we're going to talk about geology in this class in a few weeks, but this word geologically active, what I mean by that is that if a planet is geologically active, that means there are active volcanoes, earthquakes, and those sorts of things. So, the Earth right now is geologically active. There are volcanoes and earthquakes going on all the time. And actually, even though earthquakes and volcanoes can be devastating, for the entire planet, geologically active is a good thing. It means that we have an atmosphere that can protect us from things like solar wind and radiation. And how would the atmosphere protect us? How would volcanoes and earthquakes protect us from something that's coming from space? Well, that's a story for another time. Stay tuned when we talk about the atmosphere. We'll talk about that. So the Earth is geologically active, and Mercury is geologically active, not for the same reasons as Earth, but it is geologically active. Venus and Mars are not geologically active. And so because they don't have this active geology, they don't have something called a magnetosphere, which means that they are exposed to something called the solar wind and their atmosphere is being stripped away. Venus has a ton of atmosphere. In fact, the pressure on Venus is 900 times greater than the Earth's, so you'd be crushed like a soda can on Venus. Whereas Mars has a very, very thin atmosphere. It's not breathable at all. Now, but we can still see evidence of volcanoes and earthquakes on both of these planets, Venus and Mars. Venus is just dotted with lots and lots of volcanoes, and Mars has volcanoes and canyons bigger than anything that we found on the Earth. So we have evidence that all these four planets were geologically active at one time. A couple of them are dead right now, but they were all had their own geological time in history. Next zone is the asteroid belt. So this is between the orbits of Mars and Jupiter. Mars is the last planet of the inner planets. Jupiter is the first planet of the outer planets. And if you look at this picture right here, you probably, if you learned about or studied or read about the asteroid field, you might have seen a picture like this. All these asteroids kind of one nice big ring going around the sun. The asteroid belt looks nothing like this. This is complete fiction. And if you've seen movies like Star Wars or space movies where they're flying through an asteroid field trying to dodge the asteroids, it doesn't look like this. So the asteroid field is mostly empty, or I keep on saying asteroid field, asteroid belt, same thing. It's mostly empty. The reason that we call it the asteroid belt is that, and I also should mention that asteroids are all over the solar system, not just the asteroid belt. But the reason that we call this zone of the solar system the asteroid belt is that statistically, this is the place where you would most likely to find asteroids. So we know hundreds of thousands of asteroids with a diameter greater than 1,000 kilometers. Most of the asteroids reflect very little light, and so that means that it makes them very hard to find. If you were going to go stand outside on a nice clear night, you can spot planets with the naked eye because they reflect so much light. But asteroids are so dark that they're really hard to find unless you have special equipment. Some comets are born in the asteroid belt. Last thing to say about the asteroid belt there. If you ever want to be an astronomer, finding asteroids is definitely one of the biggest tasks out there right now. Finding planets, not so much. Those are hard to find. They're few and far between. Next zone of the solar system is the outer planets. These are where the gas and ice giants live. So these are very large planets. In fact, in this picture right here, you have the sun behind these four planets. So you kind of get a scale of how large these planets are against the sun. So you might notice, of course, that the sun is huge, right? If we were going to put the Earth on this picture somewhere, we could. I don't know if you can see my mouse right now, but right now my mouse is on top of a storm called the Great Red Spot. If you just Google a picture of the Great Red Spot on Jupiter, the Great Red Spot is a 400-year hurricane on Jupiter, and it's large enough to contain 3.5 Earths. So these planets are very big in their own right. These are mostly made of gases. This is why they're called the gas giants. We don't know of any solid surfaces on these planets. There might be. We just don't know. We've tried to send probes into the atmosphere, but all the probes that we have sent into the atmospheres of these planets were very soon lost short after, which we were expecting that. One cool thing about these planets is that all these planets have multiple moons. Now, when I say multiple moons, Earth, of course, has one moon. Venus and Mercury have none. Mars has two, even though Mars's moons are kind of puny. They're more like kind of captured asteroids. But all of these have at least more than 10. Jupiter has around 60, and a recent discovery showed that Saturn has almost 90 moons, 90. Neptune and Uranus have around 15 to 20 each, but it's been so long since we sent any probes to Uranus or Neptune, they might have more than that. All of them have a ring system, so we know, a lot of people know Saturn right here for its nice, beautiful rings. Not a lot of people know that all four of these planets actually have a ring system. This takes some powerful telescopes to see them, but they all have rings. The Earth, of course, does not have a ring. And even if we did have them, the orbit of the moon would quickly destroy it. So that's the outer planets, gas and ice giants. Last zone of the solar system is the Kuiper Belt. And if you've never heard of the Kuiper Belt before, that's okay, because it was only discovered in the last 10 years. This is why I kind of say I'm not going to make you guys memorize too much about the solar system because it's constantly changing. Kuiper Belt is past the orbit of Neptune, so that's the last planet of the outer planets. Contains objects like Pluto, Waimea, and Makemake. And if those names sound weird to you, well, it's because that most of these objects are discovered in a Hawaiian observatory, so of course they get Hawaiian names. And you might recognize that name Pluto as like, hey, wasn't that a planet, or didn't we call that a planet at one point? If you still want to call a planet, you can call Pluto a planet with me. It's not going to bother me at all. Pluto is in the Kuiper Belt, and there are lots of Pluto-like objects out there in the Kuiper Belt that are still being discovered to this day. So it's very much like the asteroid belt, except these objects are a lot bigger and for the most part a lot colder as well. There's lots of frozen water, methane, and ammonia. Now on Earth, we have lots of frozen water, right? I mean, you guys, most of you live in St. Louis, you've seen frozen water fall from the sky quite frequently, I imagine. Methane, that's a gas on Earth. We use methane to heat our houses. If you have gas lines running to your house for your dryer, water heater, or heater, methane is the gas that is used to heat your home. And the Kuiper Belt is so cold that methane is not only a liquid, but it is a solid ice. So these are very cold bodies. They're so far away from the sun, they don't get much heat. Some comets are also born in the Kuiper Belt, just like the asteroid belt. All right, so those are our 4 solar system zones: inner terrestrial satellites, those dense rocky planets. Then you have the asteroid belt. Then those gaseous, the outer gaseous satellites, where maybe there's a solid surface down beneath those clouds, but nobody really knows for sure. And then the Kuiper Belt, which is kind of like the asteroid belt, but they're a little bit bigger and colder than the asteroids. So I just wanted to give you the quick tour of the solar system. As always, if you have any questions, please let me know, and I'll see you in class.